Welcome to aminacademy.com. In advanced calculus regarding mathematical induction, let us do some solving problem. Look at this. Prove that 1 square plus 2 square plus 3 square up to n square equal to 1 over 6 n into n plus 1 into 2n plus 1. Here, by using mathematical induction, let us prove this statement. Now, assume the statement is true for n equal to 1. So 1 means left side we have to put 1 because n square is 1 square. 1 square equal 1 over 6, n equal to 1, 1 plus 1, n plus 1, that is 2 into 1 plus 1, which is equal 1 square is 1, 1 over 6 into 1 into 2 into 3 is equal to 1. So it is 1 equal to 1 true. That means the first statement is true. Then the second statement, it is true for n equal to, okay. Assume the statement is true for n equal to k is an any positive integer. Now 1 square, the statement is 1 square, 2 square plus 3 square plus n square, then is k square, which is equal 1 over 6 k plus 1 into 2k plus 1. Then adding k plus 1 square factor both sides. What we have? But here 1 square, 2 square, 3 square up to k square, and adding k plus 1 the square both sides, which is equal 1 over 6 k plus 1 2k plus 1 plus k plus 1 the square. Then which is equal k plus 1 a common factor, that which gives 1 over 6 k into k plus 1 k into 2k plus 1, because so k plus 1 is common out, therefore 2k plus 1 plus k plus 1, which is equal k plus 1, then 6 is a LCM, then k into 2k plus 1 is 2k square plus 1, 2k square plus k plus 6k plus 6, 6k plus 6, because this 6 is multiplied here. Then which is equal k plus 1 over 6, 2k square plus 7k plus 1. Then factorizing 2k square plus 7k plus 1 we can get is k plus 2 into 2k plus 3. That means 2 into 1 is 2, splitting 2k square plus 7k plus this is 7. 2k square plus 2k 2k square plus k plus 6k 7k, then into 6 here because multiply with 1 6, then it's 12, then 2 into 6 is 12, splitting 12 is 3 into 4, therefore 2k square plus 3k plus 4k plus 6 by 6, which is equal k plus 1 k 2k plus 3 plus 2 2k plus 3 common factor by 6, then k plus 1, that is 2k plus 3 and k plus 2 by 6, which shows that statement is true for, which shows the statement is true for n equal to k plus 1, because n here, that is 2k plus 1 is 2k plus 3 and k plus 1 plus 1 is k plus 2. It is true for k plus 1. Therefore, the statement is true for this one, and if it is true for n equal to k. But since it is true for n equal to 1, so for all above, from all above statement, we can say we can say we can say 1 square plus 2 square plus 3 squared up to n square equal to 1 over 6 n into n plus 1 to n plus 1. The statement is true. We prove. Hence, we prove. Hence, we prove. One more example we can do now. Look at here. Prove that x power n minus y power n has x minus y has a factor for all positive integers. That means we have to prove this x minus y is a factor of x power n by minus y power n. Then look at here by using mathematical induction. By using mathematical induction. By mathematical induction, n equal to 1, first statement, n equal to 1, then we can say x power 1 minus y power 1 has x minus y as a factor. Of course, x to the power 1 is x minus y. So x minus y is a factor of x minus y. Then assume n equal to k. That is true for k is any positive integer. Then x power k minus y power k equal has x minus y a factor. Consider x k plus 1 y power k plus 1. That is k becomes k plus 1. Now which is equal x power k plus 1 x power k plus 1 minus x power k y plus x power k y minus y power k plus 1. That is, we are introducing the terms minus x power k y plus x power k y. Then take out x power k, a common factor here, x minus x power k, one means it is y. Here y take out x power k minus y power k. Further factorizing, here the first term operates here x power y as a factor, and the second term has x minus y as a factor. So the first term of right side has x minus y as a factor, x minus y as a factor, and the second term on the right side also. Right side also has x minus y as a factor, because the above assumption Therefore, thus we can say x power k plus 1 minus y power k plus 1 has x minus 1 as a factor if x power k minus y power k does. Therefore, we can say it follows that k may be any positive integers. Suppose x cube, k is 3 means x cube minus y cube. Then in that x minus y is a factor. Then x minus 4 minus y minus 4 has a factor of x minus y as follows. Therefore, we can say x power n minus y power n has a factor x minus y. Hence proved. So far we discussed mathematical induction, using mathematical induction, some mathematical statement. We have done. Please subscribe our YouTube channel.